Okay, let's dive right into this explainer by putting you directly into the middle of a pretty visceral survival scenario. I want you to picture this. It's late autumn. The temperature has been plummeting steadily for the past 2 weeks, and it's becoming undeniably clear that those simple sleeping arrangements that got you through the summer, yeah, they're absolutely not going to cut it for what's coming. You desperately need a shelter. We're talking walls, a roof, and an enclosed space that can actually trap the heat of a fire and protect you from that freezing outside air. Now, think about the stark contrast between how we solve that problem today versus how our ancestors did. Today, if you need to build something, you just head down to the local lumber yard. You buy some steel, maybe hire contractors with a 5-week timeline and a shiny set of blueprints. But in our survival scenario, you have literally none of that. All you have is the raw, unmodified, natural environment around you. You've got some stone tools, and most crucially, you have the transmitted, accumulated knowledge of your ancestors. And ancient humans regularly produced absolutely incredible structures from this exact situation. They weren't primitive, they were wildly, brilliantly adaptive. Section 1. Rethinking wood and stone. So when we look out at a forest today, we mostly just see wood, right? But ancient builders possessed this highly complex timber taxonomy. They didn't treat wood like it was just one uniform material. They knew precisely which species had the load-bearing strength you'd need for horizontal beams. They knew exactly which woods had clean splitting properties, meaning they could be worked into flat boards using nothing but stone tools. They sought out very specific, highly flexible species for weaving walls. And, maybe most importantly, they knew which woods naturally resisted rot when placed directly in the soil. And hey, when natural rot resistance just wasn't enough, they applied early engineering techniques. They would actually fire harden and char the bases of wooden posts before embedding them in the dirt. That essentially created an outer shield against moisture and insects, vastly extending the functional life of the wood. To really put this sheer scale of our building history into perspective, let's talk about the number 400,000. That is how many years ago ancient humans were already manipulating their environment for structural stability. Over in France, at sites like Terra Amata, dating back roughly 400,000 years, archaeologists have uncovered these very specific arrangements of stones. And these weren't just random piles. They were deliberately laid foundations used to anchor organic shelters. It just proves that this deep, intuitive understanding of structural base weights is profoundly ancient. Of course, as human populations expanded into colder climates where timber was incredibly scarce, they had to adapt. They turned to what we call dry stone construction. And let me tell you, this isn't just mindlessly stacking rocks on top of each other. Since they didn't have mortar to hold things together, ancient builders were basically solving a massive, heavy, three-dimensional puzzle. They had to use some seriously sophisticated spatial reasoning to select, orient, nest, and physically lock all these irregular rock shapes together. They had to perfectly manage weight distribution so the walls wouldn't just completely collapse, especially at the highly stressed corners. Section 2. Engineering with organic materials. Okay, so when timber and stone were either too scarce or just completely wrong for a mobile lifestyle, ancient humans turned heavily to organic materials. And this led to some of the most extraordinary and ingenious architecture in all of human history, which brings up a really fascinating structural problem. How exactly do you bend a mammoth tusk? Out on the freezing Ukrainian steppe, builders constructed these famous mammoth bone houses. But mammoth ivory is heavy, it's incredibly rigid, and it is notoriously difficult to modify. Yet, somehow they managed to create these beautifully arched roof supports out of those rigid tusks. So, how did they pull that off? Well, they didn't just use brute force, they actually applied a sophisticated material science process. First off, they empirically assessed the natural curve of the tusk. Then, they soaked the ivory in water. Third, they applied highly controlled heat. This specific combination fundamentally altered the flexibility of the bone. Finally, they shaped the tusk to fit their exact structural needs and just let it cool, locking in that brand new arched form. I mean, this is applied materials engineering, pure and simple, discovered empirically over generations. Now, there is actually a massive blind spot we have when looking at ancient history, and it's known as preservation artifact bias. Today, we typically just find stones, bones, and maybe the occasional piece of petrified wood. But what they were actually using in massive, massive quantities were woven plant fiber walls, layered grass roofs, and intricately twined baskets. Plant fibers rot away entirely in most soil conditions, so they're literally invisible to archaeologists today. But back then, woven wall infills were incredibly lightweight, and layered grass roofs, where each layer sheds water directly onto the one below it, were a highly, highly advanced way of blocking out wind and heavy rain. And you see that exact same level of processing applied to animal skins. You can't just throw a raw animal skin over a wooden frame. It'll dry completely stiff and brittle, or it'll just rot immediately in the damp. To create shelters that were lightweight, thermally insulating, and actually portable, ancient builders had to manufacture what we could call construction-grade hide. This meant executing some pretty complex physical and chemical processing. They had to meticulously remove all the inner fat, mechanically work the skin to break down its protein matrix, and then apply smoke curing or brain tanning to absolutely halt the rotting process. Section 3. Clay and Ancient Joinery. So we've talked a bit about walls and roofs, but how did these ancient builders completely seal their environments against a biting wind? And how on earth did they hold these massive structures together without a single piece of metal? Well, the answer to sealing the environment is unfired clay. Ancient builders understood that simply adding water to clay-rich soil created a highly workable material that hardened significantly once it dried. It was absolutely perfect as a draft sealing plaster to fill in any gaps in their wooden or stone structures. Plus, they understood that thick walls of clay created a dense thermal mass. That's an engineering property that basically absorbs heat from a central fire and slowly releases it, keeping the whole interior space warm long after the fire has actually died down. As for holding it all together, we really have to rethink fasteners. Today, we completely rely on the mechanical engagement of metal nails and screws. But ancient joinery, that relied on pure physics and geometry. They engineered structural connections using these incredibly complex cordage wraps. And we aren't just talking about tying a simple knot here. This was friction-generating lashing, specifically designed not to loosen under dynamic loads, like heavy winds constantly pushing against the side of a shelter. Alongside this, they used brilliant mechanical interlocks like the mortise and tenon joint. That's where you carve a projecting piece of wood to fit perfectly into a cavity on another piece, creating a joint that resists pulling forces in multiple directions without a single drop of glue or a single piece of metal. Section 4. Masterpieces of Hybrid Construction. Okay, this is where all these individual elements synthesize into something genuinely astonishing. Ancient builders did not limit themselves to just one single material. They actually acted remarkably like modern composite engineers. They would routinely combine radically different elements. For example, they might use heavy mammoth bone for a rock-solid foundation and then transition seamlessly into a wooden post superstructure for the walls. Or picture this design. They would mix the heavy, unmovable, and totally weatherproof stability of stone windbreak bases, and then they'd top the whole thing off with the ultra-lightweight, incredible water-shedding properties of a layered woven grass roof. Then, of course, there's wattle and daub. By infilling woven, flexible plant fiber panels with wet clay, they created a magnificent composite material. The woven fibers essentially acted just like modern rebar does in concrete, preventing the clay from cracking and crumbling as it dried out, while the clay itself provided the thermal mass that those thin little fibers lacked. And when you put it all together, you get structures like this. Lashed wooden frames that can flex against the howling wind, dense stone floors for stability and ground insulation, and meticulously processed hide entrance covers to trap the heat inside. It was this brilliant hybrid approach, combining the exact, precise strengths of every single material in their landscape, that reliably produced structures capable of keeping 20 people comfortably warm straight through the brutal, freezing depths of an Ice Age winter. Which really brings us to the core thesis of this entire explainer. The sophistication is in the knowledge, not in the materials. If we circle right back to that autumn freeze survival scenario from the very beginning, you quickly realize that if you do survive, your true lifesaver isn't the wood or the stone or the clay itself. It is the invisible, empirically field-tested knowledge transmitted across tens of thousands of years of human survival. So I want to leave you with a final, slightly provocative thought to ponder regarding all of our modern conveniences and, frankly, our own lost generational knowledge. Without a hardware store and without a set of blueprints, how long would you survive using only what is in your backyard right now? Think about that the next time you walk past a simple pile of stones or a fallen tree. Thanks so much for joining me for this explainer, and keep questioning the world around you.
NextGen Hustle. Like, share, subscribe.